Hi folks, before you see my little Westinghouse 3600 watt generator. You may have seen it before if you've seen some of my previous videos, but I'm going to talk about a few very relatively simple modifications I've made to this generator that you may or may not want to consider for your own units. These changes include, or these modifications include a fuel tank drain system. I have pretty much come to the conclusion that the use of a fuel stabilizer for long-term storage is pretty much a snake oil deal. The gasoline does seem to go bad regardless of whether it has stabilizer in it. So I've now come to the conclusion that emptying the tank and the carburetor is for long-term storage is probably the best approach. I also got this generator, I thought, at a pretty good price, at less than $300 delivered to my door, and it was listed as 97 pounds, but I thought, well, I don't need a wheel kit, because they wanted almost $100 for the wheel kit, but I've kind of changed my mind about that, and so I'll talk about a wheel kit that I installed on this. Also, this unit is not equipped with any kind of a shield between the muffler and the alternator, and we'll talk about a heat shield. And also I did a little testing to see how effective this shield might be that I'll present. Finally, I had an issue with carburetor. We'll go into that in a little more detail later. And ended up changing out the carburetor. And so finally, once the carburetor is replaced, we'll do another load test on this unit to make sure that we still have unit capacity equal to or better than what we started with. Okay, the tank drain system basically consists of a T, which was cut into the original fuel line here, brought this line out, and then put just an external valve on it, a second valve. And you might think, well, that's a lot of trouble just to drain your tank, but it seems like I never get the tanks drained, and the first thing you know, I've got bad gas in there if it's been in storage for a period of time. Just attach a 1/4-inch line onto the valve and drain into a container. In a few minutes, the tank is empty. And part of my procedure then is to go ahead and start the engine, either start the engine or remove the plug from the carburetor to empty the carburetor of fuel. The wheel kit is basically things that I had laying around the shop. The wheels were salvaged from another piece of equipment that had long since been turned down. This is just a piece of 3/4-inch galvanized tubing that's bolted to the top, and the handle here is a piece of 1/2-inch conduit that's slid inside the 3/4, and basically you just pick the unit up, move it as you wish, and I believe it's going to work fairly well. It certainly didn't cost me $100 in parts, because everything was pretty much from salvage material that I had here in the shop. At 97 pounds, it didn't seem that bad, but then you get another 4 gallons of gasoline in there, and it's a pretty good load. The axles for the wheels was a fairly simple approach. Basically, let me take one of the wheels off. The only real catch here was, I believe this was a 1/2-inch diameter shaft needed for the wheel, and about a 3/8, I believe it was, bolt needed to go through the existing clamp that was set up to receive the wheels. So basically all I did was to take a 1/2 inch bolt and a 3/8, put them together and just put a bead of weld around the center, and it made a simple axle. And then these keeper pins are inserted to keep the unit from falling off. This shot shows the wheel in place. When we put the wheels on the, I'll call it the rear of the generator, it raises the frame in the back, so the rubber pads for the front need to be extended. And here you can see where I've extended it. The original rubber pad is hooked to the bottom of it. All right, I'll take this particular extension is loose, I believe. But let me just take this off, and I'll give you a little better view of the foot extension. It's pretty simple, really. We have just a bolt going through this spool. Spool is made of it's a 3/4 inch conduit. It's about 2 1/4 inches long, and then washers were tack welded to the either end to give a bit more support to the rubber foot. So basically, this is how it goes together. Now moving on to the details concerning the heat shield. As you can see, Westinghouse has a pretty decent safety shield for people, but if I slip this out of the way, and I've taken the screws out, so we'll take a quick look. This portion of a muffler is only inches away from my alternator, and I became a little concerned about the life of the alternator because the heat radiated from this. It would have been nice had Westinghouse put some sort of a heat shield down here. And I've started doing some temperature checking. In fact, right here you'll see I have a couple of heat probes, one on this side and another probe over here on the opposite side, so I can kind of compare the side of the alternator that's facing the temperature of the side of facing the muffler against the opposite side, and get some idea just how much heat is being liberated into the alternator. And my approach, or at least what I'm going to try, is to add a shield, which I have made up here. I'll bring it around, and basically the shield, this portion of the shield, will slide between the muffler and the alternator, and then it gets bolted on the top with the bolts that are holding the existing shield. It's also anchored here, and I do have a strap that goes under the alternator, and it anchors on the opposite side. This has still got to be kind of checked out to make sure vibration doesn't cause it to be an issue. So this will go in like so. This will set about here. These are where the two existing anchor bolts for the existing shield go on. Then the original, I'll call it the people shield, will go over this. And down like so. So this will give me a piece of sheet metal between the muffler and the alternator, and there's about perhaps a 1/4 of an inch between the sheet metal here and the muffler, and probably maybe a little over an inch from the shield to the alternator itself.
All right, we've got ready to do a little test here to see if this heat shield does any good or not. And what I've got is, again, this is just a cooking thermometer with the base unit, which is this device, and then the receiver with the display. And the top one is probe number 1, which is nearest the muffler, and then probe number 2 is on the opposite side of the alternator. And as you see, the engine hasn't been started. It's 43 degrees, cool day. Also, I have plugged into this unit a 1400 watt heat gun, which is just sitting here on the floor. I'll start the unit, and my intention is just to run this unit and record temperatures for about a half an hour, and I'll compare that back to when I ran this without a heat shield on it and see if there's any improvement or not. So with that, we'll start up. All right, here comes the load.
We'll take a little break in the video here and talk about a problem that's come up. We started the temperature monitoring on the alternator using 2 probes here, which were taped to either side of the alternator. One was on the side that has muffler, and there was the second probe was put on the other side. This thermometer is, as I said, is a cooking thermometer, and basically it transmits by radio signal to this receiver that I have in my hand. And as you see, I thought, oh, this is a wonderful approach to collect my data. I'll just set this up, let it run for whatever length of time till it stabilizes. And you can see right now it's showing both probes at about 70 degrees. So, and everything looks nice and smooth. But when I began to started the engine and began to take data, I found that the temperatures were changing sometimes as much as 10, maybe 20 degrees within a second or two, and there was no real reason. Frankly, when I got through with the data, I just didn't trust it. I'm not sure what the problem is. Maybe it's a vibration from the generator. Maybe it's a magnetic field from the generator that's being picked up by the probes and interpreted as a temperature signal. But anyway, this was very erratic. So I found myself in a situation where I just was not getting temperature data that I felt comfortable with. So I had this multimeter, which had with it a probe, a thermistor probe, very simple. It only had, so I taped this thermistor in on the side between the muffler and the alternator. Again, attached it, just taped it to the alternator, and used this device to record my temperature readings. And it seemed to work very, very stably. The only thing is, it did give me temperatures in centigrade only, but there's no problem in converting centigrade to Fahrenheit. So the data collection, I'll show you the results here. I took the data and put the data in a spreadsheet and let it plot the information on it. So the lower line here is the temperature curve with a shield. The red is a temperature without the shield. And you see, we started, it was probably about as I recall, it was about a 43 degree day, a 45 degree day. So the engine was already, you know, running around 65, 70 degrees from the previous test when I started this over. And the first run was with the shield in place, and you see it climbs, it climbs, it climbs, it climbs, and finally it reaches a stable temperature of about 150.8 degrees, give or take a little bit. And when I saw that I had a pretty temperature was not changing, I shut it down, took the heat shield off, and then restarted. And the red curve is higher because, again, the alternator was still warm from the first test. So, you know, we're almost at 130 degrees when we started here, and it very quickly climbed up. I didn't have to run it as long on the second test before I got to what I would consider a fairly stable temperature. It didn't seem to be climbing, and that was at 183.2 degrees. So basically the temperature difference between these two is around 32 degrees, give or take. So the heat shield is in fact doing some good. All right, well, this will complete the portion of the testing of the heat shield, and I want to move on to another issue that I'm having with this generator, and that is that under light load conditions, light or no load conditions, the generator surges. And this next part of the clip that you'll see the throttle going up and down, and this is not a good situation, because I'll be using this generator at times with a very light load on it, and I don't want the light bulbs or anything that's hooked to it experiencing this changing voltage due to the surge issue. So this will be the next issue that we'll take a look at. Now, you can probably hear in the background the engine surging, and if you look up, you can see perhaps the movement of the throttle arm as the engine goes up and down. Now you'll see my hand, I'm gently pushing the choke slightly closed, and the unit smooths out. This is a classic issue of running lean under partial load. As you see, I have the carburetor in my hand, and you're looking at the discharge side of the carburetor, and in the center where my thumb is pointing is the brass adjustment screw on the secondary pilot for fuel air mixture, and it's sealed in there without any way to adjust it. Okay, today my replacement carburetor came in the mail to me. It looks like it will fit properly, and of course one of the important things is that right here at my thumb I do have an adjustment on the pilot circuit, so I'm hoping this replacement carburetor will work better than the original, which had no adjustment on it. Okay, we've got the new carburetor in place on this Westinghouse unit. Again, this is a WGen 3600 watt rated generator, although the best I've ever gotten out of it's about 3100 watts. Right now we have a power cord just a piece of Romex wired in through this outlet going over to our load bank setting here in the background. And I also have a heat gun lying here on the floor. And the reason for the test at this point is to try to see how the unit performs with the new carburetor. The problem I was having was that under full load it ran fairly well, but it would surge under no load conditions and low or no load conditions. So that was not desirable, so I ended up changing out the carburetor. So with that said, what we'll first do is to start the engine up. I will let it run for a few seconds, and then we'll put this 1400 watt load on from this heat gun and then back off. And if it works okay under no load conditions, then we'll probably move forward and do a load test and see what we can do under full load conditions. All right. Ignition on, choke on, gas on.
On startup, the unit starts without load and runs smoothly without surging. Then you see me pull the trigger on the heat gun, applying a 1400 watt load, allow it to run for a few seconds, then I shut it back off, and the unit runs smoothly still without load, without surging. Hooray! Now we'll move on to the load test.
I did a prior video on this load. We're using this homemade load bank, but basically we have a box full of heaters underneath here with a blower fan and some toggle switches here, which allow me to switch in parallel and series combinations of the resistors in the load bank. And then we've got a power monitor here that will, among other things, it'll indicate the power that's being delivered into the load bank. Also, this is a main breaker which acts as a total disconnect for the unit. So I think we'll probably go ahead and start up, and I'll get the engine started again, and we'll see how it does under load conditions. My first step is to plug in the fan, which will blow air across the resistors to help keep them cool.
The drain system shown in this video will leave a small amount of fuel in the tank because of the design of the tank outlet. You can mop the remaining fuel out, but that's a lot of work. I'm betting that the remaining fuel will evaporate and be gone within a year. However, I may be wrong. One thing that is for sure, that if you're using ethanol containing fuel, given enough time, the ethanol will absorb moisture and that gooey mess will separate from the gas and start corroding the fuel components. The wheel kit, in my opinion, is a back saver and worth the trouble. Build your own kit, or if you pay upwards of $100 for the kit, it may be worth time, money, and pain, particularly if you find yourself in a doctor's office as a result of moving this unit around. The heat shield is hard to evaluate. However, in theory, the lower the operating temperature of the alternator, the more hours one should get from before insulation failure. In my testing, I saw the shield cut the surface temperature by 32 degrees on a day when the ambient temperature was 43 degrees. Without the heat shield, the surface temperature of the stator rose to 183 degrees. During the test, the generator was loaded to less than 40% of its rated capacity. In my limited searching, I found that most magnet wire is rated for a maximum of about 311 degrees Fahrenheit. It's my opinion that on a hot day operating at full load, it's possible that winding temperature may approach a level that could accelerate insulation failure. The replacement of the carburetor was a complete success. At no load, the generator showed no tendency towards surging. An added bonus was that during the load test, the peak output power was found to be 3,300 watts. In an earlier test with the original carburetor in place, the unit peaked out at 3,100 watts. For those of you who are interested, the elevation of my shop is at 1,130 feet, and the ambient temperature during the load test was 40 degrees Fahrenheit. Thank you for watching. Hope the information is useful.